Hey guys, this is Mitch with FinePoint CGI, and today we're going to talk about how to create a multiplayer game using Nakama. So we're going to go through the process of setting up Docker and setting up our Nakama Docker instance. We are going to go ahead and set up our login screen, and then we're going to go ahead and set up a ready screen and do our first RPC call, which will be really cool. We're going to learn a little bit about RPC calls while we do that. And then we're going to talk about building a small character controller and setting up our RPC link with that so we can synchronize our movements between our Nakama games. Then we are going to go ahead and set up a small game state so that way we can have a win-loss system. So like when you shoot somebody and kill them, it'll say I win and I lose. Unfortunately, we don't go much farther than that because there's a lot to cover in this tutorial. And then finally, we go ahead and put Nakama out on the internet on my DigitalOcean account for us to play with so we can play our game online. So that's what I have in store for you guys today. So let's go ahead and get started. All right, so the first thing that we have to do is we have to talk about Nakama. So what is Nakama? Well, Nakama is a open source server that basically does a lot of that heavy lifting for you for your back end for your game. So it has some really cool features. If we kind of scroll down here, you can see some of the people that have used it. So like Paradox Interactive, Zynga uses it for a lot of their games. Huge uses it. Things like that. So it's a pretty, decent back end. If we kind of scroll down here, you can use it for real-time matchmaking and real-time games. You can use it for leaderboards and tournaments and currencies and economics, things like that. You can go ahead and use it for a friend system and a chat system and stuff like that. And you can go ahead and expand it to work with other things using TypeScript, Lua, or Go. So one of the nicest things here is that you can actually basically make it so that your project is expandable and you can actually add really cool features. So, if you wanted to run a small script when people connect or go ahead and do something on your server, you can actually do that. So you could create like a back-end little script that, goes, selects the database, fetches some data, maybe returns it, stuff like that. That's stuff that you can actually extend your Nakama cloud instance to do, if that makes sense. Now, if we scroll down a little bit more, one of the nice things about Nakama is it is usable for your own products for free, and you can actually host it on any server you want. So you don't need to use the Nakama commercial edition to release your game. You can actually just release your game and have it work. And the last thing is, here's all the engines that it works, as you can see, that it works with. As you can see, we have Godot right here. So that's really cool. And they also have, of course, Unity, Unreal Engine, and C# here. So if you're using Godot C#, which this tutorial is not, but in the future, we're going to do a C# tutorial specifically. So it's nice to see that they actually have a C# version as well. So that's basically Nakama. Nakama is a really cool back-end server. I used to use it for social aspects back when I worked in the industry. So it's a decent server system. So now that we kind of know what Nakama is, how can we set this up so that it works on our machine? Well, what we can do is we will need to have a Docker installed. So what we can do is we can head over to Docker here. And if you don't know what Docker is, I'm not going to go into a huge thing about it, but it's basically a virtual machine for applications. So you could run applications inside of their own containers, basically, like their own little boxes, and interact with them. So it's really useful for things like Nakama or SQL, or if you are doing something like a web server of some kind, or if you need an operating system for a specific reason, this is actually a really good route to go. So what we can do is we can click on getting started here, and we can go ahead and download this for Windows and install it. So I'm going to go ahead and download that. Now you will see that it says that it's preparing for an update. That's because my machine already has Docker Desktop, so it's actually updating me to 4.8, which is fine because I needed to update anyway. So we're going to let this run, and I will be right back. All right, so now that we have this installed, let's go ahead and click close here. So we'll go ahead and close that. And you will see that Docker has started on our end. So it does take a few minutes. Docker is a huge application that has all sorts of stuff in it. So it's going to take some time to load. Now, one of the things that you have to know is you have to have virtualization enabled on your computer. And if you don't have that, I'll leave a link in the description below to where you can enable Hyper-V and things like that, because you will definitely need Hyper-V for any of this to work. So let's let Docker Engine start, and it looks like it's already started, so that's awesome. And you'll see that there's all sorts of stuff here that says, hey, here's some featured images. Here's some things that we can use. So like if we needed a Nginx web server, or if we need a redress server, or if we need a Postgres or a MongoDB server, we can actually just put it together right here, and we don't need to worry about a thing. Instead of going through that, what we're going to do is we're going to use a Nakama Docker compose file. It's going to be a YAML file, okay? And the beauty of Docker is that the Nakama team actually built a YAML Docker compose file for us, so it'll just build our environment for us. So what we'll do is we will come over to their instruction manual, and I'll leave a link to this in the description below. And we can come down to their Docker Compose YAML file here, okay? Now, it's up to us on which one we want. The first one right here is using CockroachDB, and the next one is using Postgres. So it's really up to us on which one we want. But in my case, I'm going to grab the CockroachDB one because it's a lighter weight database than Postgres is. But if you're doing a production workload, it might be a good idea to use Postgres. It depends on your use case, really. So what we'll do is we'll grab this file right here. We'll go ahead and copy this. And then what we're going to do is we're going to go ahead and open up VS Code here, just like this. You'll see we got VS Code. And what we'll do is go File, New File, and we're going to go ahead and paste that in, okay? And then what we're going to do, and you'll see that it's auto-detected it as a YAML file. And what we'll do is we'll go ahead and hit Control S, and we will save this out as our docker-compose YAML file, okay? And what I'll do is I'm going to go to Terminal, New Terminal, and we'll type docker compose up. And what that should do, if we've done everything correctly, is it's going to attempt to pull our Nakama files. So you can see right here, it's pulling all of our Nakama files, and it's going to go ahead and set up our entire environment for our Nakama system. Now, in the future, we'll go ahead and set this up so that way we don't actually have to use Nakama or anything. We could actually just use our own server, and you will see that it is up. So if I open up Docker Desktop, you will see that if I go over to containers, you'll see that Nakama is now running. Now, one way that we can actually check to see if Nakama is running is Nakama has a port that it uses for its administration. So if I come back to my web browser here, and if I pull this down for you guys real quick, and I go to 127.0.0.1, so .0.0.1 : 7351 for the port, you will see that we have Nakama console. That means we've done everything correctly. So if we want to log in, you could just type admin, I believe it is, password, and you will see that we have Nakama running. Awesome. So it's really that simple to get Nakama running, as long as you have Docker installed. So now that we have this running, let's go ahead and jump into Godot, and let's actually start building our multiplayer system. All right, so now that we're sitting inside of Godot, let's first get our Nakama stuff set up. So we're going to go into the asset library. We're going to type in Nakama. And we're going to go ahead and grab the Nakama Godot client here. And you'll see that this is made by Nova Byte, which is one of the premier developers over at Nakama. So we're going to go ahead and download this, and we will go ahead and install this, and that's going to pull down our entire client. Now, the nice thing about this is that it has everything that you could possibly need, including your mono utilities. If you're doing C#, it actually has all your C# bindings right here. So it solves a lot of problems. Something else to keep in mind is that there is also the Nakama client in GDScript and WebRTC and Nakama add-on. So these two are super useful if you want to use WebRTC for your Nakama stuff, or if you want to use Nakama REST API stuff, you can actually do it right here as well. Now, this one is the Nakama official supported Godot. This one here is like a community supported version, and this one here allows us to use WebRTC, which is really, really cool and actually is lighter on your system's resources. So I might do a tutorial on this one eventually. Now that we have our Nakama stuff installed, let's go ahead and pull down the online code that Nakama provides on their repo, because they actually don't have it in here, but it allows us to have an abstracted layer with our code and makes things a lot easier for us to work with Nakama. So what I'm going to do is I'm going to right click on my add-ons. I'm going to create a folder, and I'm going to call it Nakama Online. And I'm going to go ahead and go out to, so if we go out to their demo fish game here, they actually have a section in here for auto load section here. So if we come into here and we take a look, we have an online and an online match. Now, those are the two things that we really need out of here. So let's go ahead and just kind of open up both of these guys and basically just grab this code out of here. This is a bunch of code that Nakama has built for us that basically makes things so much easier. And I'm going to take zero credit on building any of this code. This code is all really awesome and will save a bunch of time on our part. Originally, I was going to code all of this manually, but then I found that they actually just have it here. So why recode it if we don't have to? So what I'm going to do is I'm going to come back into Godot here, and I'm going to go into Nakama Online. I'm going to create a new script, and I'm going to call it Online. And I believe this one is Online Match. So we'll say Online Match. And then we'll double click on that, Control A, Control V, and that will basically just give us a bunch of socket connection stuff that's already pre-built for us. It's like I said, it's going to save us a bunch of trouble. And then I'm going to go ahead and go File, New, Script here, and I'm going to call it Online. And then we're going to go over to their online script right here, and we're going to copy and paste this as well. Now, I will go ahead and include links directly to this in the description below, so that way you guys can actually have these scripts. Trust me, it'll save you a bunch of time if you're prototyping out your project. Now, you might want to come in here and change it in the future. You know, if you need to do some crazy manipulations of Nakama's game state or something like that, or if you want to edit, you know, maybe some of the default values that they have here. But this actually provides a very good starting point for your project. So what I'm going to do now is I'm going to make these globally accessible. So we'll go to Project Settings. We're going to go over to Auto Load, and we're going to go out to our online.gd and our online match.gd. And you'll see that my online's actually in the wrong spot. So I'm going to go ahead and put that in the correct spot. So hold on one second. Let me drag this up here into Nakama Online. Go to Project Settings. Click on the little file icon. Go into my add-ons. Nakama Online. Let's do Online. Add that. File, Online, and add Online Match as well. Let's go ahead and click Close. And from here, we can now start building our login system, and we can start building our actual game. So what we'll do is we'll go in, create a new 2D scene. We're going to right-click our 2D scene. We're going to add in a child node, and let's add in a control node. And we'll go ahead and pull this to be about this big, give or take. And we'll go to layout and center. We'll drag this to the center, give or take. And once we get this into the center, give or take, we'll go ahead and right click our control node, add in a child node, and let's add in a panel. And then we'll go ahead and make that expand all the way. So we'll click on layout, full rect, and that's going to expand that completely. Then we're going to right click our control node. We're going to add in another child node, and we'll go ahead and add in another control node. And what this is going to do, if I make this full rect, is I'm going to duplicate this 3 times. So I'm going to control D, D. And what I'm going to do is I'm going to call this login, find match. And then I'm going to call this ready screen. Okay. And what these screens are going to be used for is the first one's going to allow us to log in. The next one's going to allow us to find a match. And then the last one is going to populate when we have our ready screen. Now, you don't have to have a ready screen. You don't have to have a find match screen. Technically speaking, you could just have a login screen and then have it go ahead and do its thing. But in this case, we're going to go through all 3 of them. So I'm going to right click my login. I am going to go ahead and add in a child node, and I am going to go ahead and say rich text label, and we'll make this something about here, and then we'll duplicate it, pull it down here, and then we're going to duplicate the last one, pull it down here. We're going to say the first one is username. The next one is going to say email, and the last one is going to say password. Now, that's probably too far away, so I'll just go ahead and pull these guys up. That way we can kind of condense this a tiny bit, so we get a little bit more space back. Then what I'm going to do is I'm going to right click my login. I'm going to add in a child node, and I'm going to go ahead and add in a line edit. And we'll go ahead and put it right about here-ish. And we will change the size so it kind of comes up to about here. We'll duplicate that and pull it down. If I can grab it, that'd be great. There we go. We'll go ahead and duplicate this, pull it down one more time. And I'm going to rename this line edit to username text. Next one is email text. And the last one is password text. And then we'll do the same thing here. So password label, email label, and rich text label will be user name label. There we go. Simple enough. So now I'm going to go ahead and add some buttons here. So we'll go ahead and add a child node, and we'll go ahead and add in a button. Now you guys can go ahead and make this fancier if you want to. You guys could add in, tabs and maybe just allow the email password to log in or something like that. But in my case, I'm just going to have it all on one screen. It'll be a little bit easier for us to just put together quickly for the sake of this tutorial. So what I'm going to do is I'm going to grab that. I'm going to duplicate it, and I will move it over, providing I can grab it. There we go. And the first button will say register. And the second one will say log in. We're going to go ahead and rename these to register and log in. All right. So now that we have all this, let's go ahead and start doing our code. So we're going to right click our login. We are going to go ahead and attach a script, and we are going to create a login.gd script here. So the first thing that we need to do is we need to go ahead and connect our signals so that when we press in our log button or we press in our register button, we can go ahead and log in and or register, right? So what we'll do is we'll go ahead and click on our register button. We're going to go to node. We're going to say on button down. We're going to connect it to our login little controller thing here. We'll do the same thing with our login button down on our login. There we go. And the first thing that we need to do is we need to pull back our username and password and email. So what we'll do is we'll say var username is equal to $username text dot strip edges. And what strip edges does is in case somebody leaves a trailing space or adds a space in at the beginning, we can just kind of rip those out so that way they don't actually affect our end result. So for instance, if I type something like space funky monkey, right, space, this will fail to work because there's a space in the front and a space in the back. So we want to strip those edges so that way it just shows the funky monkey part, not the rest of it, if that makes sense. So we'll say var password is equal to $ password text dot text. We want to do the same thing, dot strip edges. Var email is equal to $email text dot text dot strip edges. All right, so now that we're pulling back all of that, what we need to do now is we need to actually create our session. Okay, so what we can say is we can say var session is equal to yield, because we have to wait for us to create our session with Nakama. We could say online, which is our Nakama online class here, this one right here that we made a global class, dot Nakama underscore client dot, and you'll see that it's not automatically doing text fill, which is one of the big problems that I have with this. But what we can do is we can say authenticate underscore email underscore async. We could pass in our email, comma, password, comma, username, comma, and you see that we go from online to Nakama client. If we go to online and you look for Nakama client, now you'll see that we do have an identifier. Nakama is not declared in the current scope. We'll fix that in a second. You'll see that it comes from a Nakama client. So if we head over to our Heroic Labs and we go to our client, Nakama client right here, we open this up and hit Control F and V. You'll see what it's looking for. So you can see it's looking for an email, password, username, if we're going to create the username, and any additional variables that we're looking for. So in our case, we're going to just pass in true because we're trying to create our username. And then we can come over here and pass in completed. So we'll say quote. And what that's going to do is we're going to wait until we get back our completed registration signal. And once that happens, then we can continue with the rest of our code here. So what we'll do is we'll come in here and we will say online dot Nakama underscore session is equal to session. And what that's going to do is that's going to set our Nakama session to our current session that we pulled back from our email authentication. All right, so I'm going to go ahead and save this, and we'll just call this our main.tscn. That way I can save and not have this throw a fit at me. And that's basically all we need to do to register our users. That's pretty much it, which is kind of crazy if you think about it, right? So this does not do any error handling at all. So that's something that we have to keep in mind. So really what we should do is we should check for any exceptions or anything like that. Like if the user put in a bad email or something like that, we should probably check for that. So what I'll do up here is I'll say if session.is underscore exception, then we'll go ahead and print our session.get underscore exception dot message, and that'll just pull back our message so we can see what's going on. Now, if you guys want, you guys can check for like invalid credentials or a bad email or something like that. And then you could actually just print that out, or maybe put a little pop-up that says, hey, you put in a bad email, right? So now let's fix this little issue that we have in our online where it says that identifier Nakama is not declared in the current scope. So the way to fix that is we just go to projects, project settings. We go ahead and click on the little file icon and peel up, go to our Heroic Labs Nakama and grab our nakama.gd, open that and go ahead and add it and close. And you'll see that that's going to fix this issue. Now, we will run into a small issue that I've noticed, that there's a cyclical reference. It does not affect the actual code, but sometimes you will see it when you are running around in your code. You'll see that it says something like this: could not fully load singleton script, possible cyclical reference. Don't worry about that. That's just Godot being really weird. Apparently, there's a bug where Godot does that every once in a while. So it's just something to keep in mind. So let's go to our login script here, and let's go ahead and hit play real quick. So we'll hit play. It's going to say, hey, there's no main to scene. So I'm going to select my current scene, and you'll see that we have our username, email, and password. So if we click on this, it's not going to do anything. So let's go take a look at our text, see if we can actually affect it. And because this is the top of our user interface, we should probably move these guys back. So we'll go ahead and drag these guys back like that, so that this guy's on top, so we can select these guys. If you put these guys below it, it's going to intercept the click, and we're not going to be able to interact with our user interface here. So make sure we pull these guys back. And let's go ahead and hit play. So if we come in here, we click on our username, we type test. For our email, let's go test@gmail.com. And for our password, let's say password 111. No capital, because I'm going to get tired of typing that. And let's click register. Now you see that nothing really happened. But if we head over to our web browser here, and we head over to our Nakama console here, and we go over to account, you will see that we have a test user account with a unique user ID. It doesn't have a display name because we must not be populating that properly. And the last update was today, which is really cool. And you can also see, if we look at our status, you can see that we have some routines that ran to register that user. So, I mean, simple enough. We legitimately have our users already put in right here. And it took us like, what, 10 seconds, right? So now that we have this, let's go ahead and do our login system. Now, our registration, our login can basically be the same thing, but just slightly different. But it should only take about 10 seconds to put together. So what we'll do is we'll close Godot. We're going to go ahead and jump over to our little project here. Click on our little script and come down here into our login button down part. And let's go ahead and do the exact same thing that we were doing. But this time, instead of creating a user, we're going to go ahead and just register a user. So what we'll do is we will grab all of this code, literally all of it, copy it, paste it. And instead of doing true right here, we'll say false. And we don't want to pass in a username, so we'll say null instead. And that's pretty much it. That's all we have to do. So we'll go ahead and save that. And we'll go ahead and hit play. And we can just say test@gmail.com. Password is password 111. Log in. You'll see that we didn't get any errors. And that's basically good to go. I know it doesn't seem like we're doing anything, but I promise if we come here and we click log in, you can see that our Nakama session actually exists. We do have a session, which means we are in fact logged in. You can see here's our token, here's our create time, here's the username that we are currently using, here's our user ID, here's our actual refresh token. So we legitimately have ourselves logged in. And like I said, it took like what? 10 seconds. So that's awesome. So now that we have our login done, let's go ahead and set up our matchmaking section. Now the matchmaking section is a little bit more complicated. It's going to be a little bit more crazy, but it still should be fairly quick. So when we use our matchmaking stuff, what we can do is we can legitimately just throw it together pretty quickly. So what we'll do is we'll go into our find match. We're going to go ahead and put this above the ready screen. That way it's, that way it flows backwards. So we can go, okay, now we're in our find match and now we're in our ready screen, right? So that'll be how that's going to work. So what we'll do is we'll come into our find match, we'll right click and attach a script, and let's call it findmatch.gd. We'll go ahead and right click, add in a child node and add in a label. And we're going to, which it didn't put it in the right spot, but that's okay. So we'll do this, and then we're going to go ahead and center it like that. And you will see that we'll just put some text here that says finding match. Simple enough. Something simple. Like I said, this is supposed to be a very simple, straightforward tutorial. So I'm not going to get any frills or anything crazy. So all it's going to do is it's going to pop up and attempt to find us a match immediately. So we'll go into our script and we'll go ahead and start scripting. All right. So first, what we need to do is we need to go ahead and connect a signal with our online match. So what we're going to do is we're going to say online match.connect, and we're going to go ahead and connect our matchmaker matched signal here to ourself, and then we are going to go ahead and attach it to a on match found, and I'm going to go ahead and make that function real quick. So we'll say func on match found, and we'll just go ahead and pass for now. So what we need to do is we need to go ahead and tell Nakama to start doing our matchmaking. Now, the easiest way to do that is to go ahead and create a small button, because that's going to make it a little easier for us to fire off the event. So what I'll do is I'll go into my find match. I'm going to right click, add in a child node. We'll add in a button right here. And I'm going to go ahead and scale that boy up a little bit like that. I'll put him right here. And I'm basically just going to go ahead and make it so when you click on this thing, let's find a match. And what we'll do is we'll make it so that, call this find match. And what I'm going to do is I'm going to go ahead and hook this up so that when you press this button, it's going to disappear and it'll just show the finding match label here. And that should make it pretty easy. We're going to go ahead and connect that to our find match, just like that. And then what we're going to do is we're going to say $find match dot hide, and that's just going to go ahead and hide that button. And then we're going to need to go ahead and set up our connection. So what we'll do then, what we can do is we can go ahead and check if we're connected to Nakama. So what we got to do is we have to say if not online dot is Nakama underscore socket underscore connected, then we can go ahead and connect to our socket. So we can say online dot connect underscore Nakama underscore socket. Okay. And then we're going to have to wait for that socket to get connected. So we're going to say yield, and we will yield our online, comma, quote, socket underscore connected. All right, so now that we have guaranteed that our socket's been connected, we're going to need to go ahead and start our matchmaking, right? So what we can do is we can go ahead and say print, quote, looking for a match. And then what we'll do is we'll pass in some data here. So the way that Nakama works is we have to actually connect to our socket, start our matchmaking, and then pass in some data. And a lot of times that data can be how many minimum players we want, how many maximum players we want. It can be stuff like if we're hooking up to a specific matchmaking group, like for instance, if you're like a diamond, platinum, or something like that. And there's a whole API reference that I can leave a link to in the description below. That'll kind of help you out there. But what we'll do is we'll go ahead and say var data is equal to, and we'll just pass in our minimum count, and we'll just pass in 2 in this case. We'll just say we're going to allow for 2 players. That way we can demo this and show it working. And then what we'll do is we'll say online match dot start matchmaking, and we'll pass in our socket. So online dot Nakama underscore socket, comma, and we'll pass in our data. And that's basically all we have to do for our matchmaking. And that's it. So what we'll do now is we'll go ahead and set up our callback that we had. So our little online on match found here, we'll go ahead and set that callback up. So what we'll do is first, when a match is found, if we go to our matchmaker matched section on our online match, so if we head over here and hit Control F, Control V, you will see that we have a signal here, matchmaker matched, and you'll see that it passes in. Actually, if I go back up here, you'll see it passes in players. So that means we have to take in a players. So what we'll do is we'll come back to our find match. We'll go ahead and say players. And what we're going to do is we're just going to print our players. All right. Now, this is going to be difficult to test, right? Because we're going to need 2 Nakama instances up at the same time for this to work. So what can we do to make this a little bit easier? So there's an add-on that will really help us out inside the asset library. So if we go over to the asset library and we get rid of this and we go ahead and add in our multi-run, and this add-on allows us to run multiples of 1 instances of Godot, so that way we can test our project. So I'm going to go ahead and download that and install it and hit OK. Then we're going to go to project settings, and we'll go to our plugins, multi-run, and we'll go ahead and enable that. Now you'll see up here on the right, we actually have a play button. So now we can actually press this, and it's going to go ahead and launch 2 versions of Godot. Simple enough. So what I'm going to do is I'm going to go into my login. I am going to click on my little script here, and I'm going to make sure that when we log in, it hides our login. So we'll just go ahead and say hide, just like that. And that should allow us to hide ourselves. And we'll do the same thing up here. And actually, you might just want to say self.hide just to make things a little bit more, reasonable here. So we'll just go ahead and do that. So that way it just hides this little area here. And then we'll go ahead and click on this. And you'll see that we have 2 logins, which I'm going to kill this because I should probably grab my panel and pull that down into my login. And I'm going to go ahead and duplicate that panel, put it underneath find match, duplicate it again, and put it underneath my ready screen. That way I just have these panels here. And that should solve that problem. So let's go ahead and run this. Let's see if that works. So we have 2 instances of Godot here. Let's first log in, test@gmail.com, password 111. Now we're going to need to register here. So let's say test2, email test2@gmail.com. Password is going to be password 111. We'll go ahead and log in, register. Let's find a match. Let's find a match. And we have some issues. Let's see. If not, Nakama is socket connection. It says that doesn't exist. Did I spell something wrong? Knowing me, I did, and I did. Socket connected. There we go. Let's try that again. That's my fault. So let's make sure that both instances of Godot is closed. And then let's go ahead and fire this off again. And let's see. So I can log in, test@gmail.com, password 111, test2@gmail.com, password 111. We're going to log in, find a match, and you'll see that it's now attempting to find a match right here. Looking for match. And let's let that sit for a minute. The thing about Nakama is it does have a upper threshold if you don't reach the number of people. So for instance, by default, Nakama with these settings, with this online match, is set for finding a minimum of 2 players and a maximum of 4. So until it finds 4, it's going to wait the full duration of 15 seconds. So we're going to wait for about 15 seconds and let this run, and then see if we get our print. And if we get our print, then we are ready to start doing some really fancy coding and making this into an actual system that talks to each other. All right, and now you will see that it is printing our objects. So we have our unique identifier here and our unique identifier here. So you'll see that it seems to be working. So let's go ahead and kill both of our Godot instances here. And let's go ahead and start actually coding our player ready screen. So this will be a little bit harder than probably what we've done in the past, because coding a ready screen, there's a lot to it. So, it's going to be a lot of fun. So what we're going to do is we're going to say, once we've found a match, right, and we can print our players, what we'll do is we will now hide our self. So we'll say self.hide. And that's going to allow us to pop back to our ready screen. Now, our ready screen is going to need to be designed to handle all of the players that show up. So what we'll do is we'll go ahead and click on our ready screen. Let's hide these guys. And let's go ahead and right click, add in a child node, and let's add in a bbox container here. What I'm going to do is I'm going to make that about yay big, give or take. I'm not being exactly perfect on this, but we'll just make it about this big, give or take. And then what we're going to do is we're going to right click, add in a child node, add in a control node, and we'll right click, add in a child node. We're going to add some text, rich text label, and then we'll duplicate that as well. Our first one will be user name. Our second one will be if they're ready or not. And what we'll do is we'll go ahead and pull our ready state over here, and we will go ahead and say not ready, like that. And for username, we'll just say test username. So that way we have something to look at. There we go. So now if we look at our container, our little control, you can see it's not quite the right size. So I'm going to go into my rect. I'm going to say my minimum size on my y-axis is 20, and that should about do it for me. And then we're going to right click our control node, and we're going to rename this, and we're just going to call it our user ready. We'll go ahead and save that. We're going to right click it, and we're going to go ahead and save branch as scene. We'll just say user ready.tscn. We're going to go into that scene. We're going to right click it and attach a script to it, and we'll just call it user ready.gd. I guess let me actually go back a little bit. So what we're going to do is when the user comes in, we're going to need to instance a copy of their username and if they're ready, right? And then we're going to need to be able to populate that data. So we need to make a script to allow us to do that. So what we'll do is we'll come into our user ready scene. We're going to go into our script. So we'll say var ready, and we'll say var username. And then down here, we're going to say func set ready, and we will pass in our ready. And what we'll do is we'll say $sign ready.text is equal to our ready. And then we'll go ahead and say our ready is equal to ready. And actually, we should probably change this to ready text. That way we don't mix up our global variables and our local variables. And then we'll go ahead and add in our set username function. So we'll come in here and we'll say func set username, and we'll go ahead and pass in our current username. And what we'll do is we'll say $sign user name dot text is equal to our current username. And then we'll go ahead and say username is equal to our current username. There we go. And that should basically allow us to set these two values here with different functions. It'll make it a little easier for us to kind of just set stuff up, right? So now if we go back to our main scene here, and we go ahead and go to our ready scene, we're going to need to add in a button as well, right? So we need to be able to click and say, I'm ready to go, right? So what we'll do is we'll right click, add in a child node, we'll add in a button, and we'll go ahead and make this about yay big, kind of put it down here, give or take, and we'll just say, I'm ready, like that. And then what we'll do is we'll right click our ready screen, we'll attach a script, we'll call it ready screen, and then we're gonna go ahead and click on our button, node, and attach that signal to our ready screen. And that'll allow us to set our ready state. So now that we have all that set up, and I know I'm going really fast, but it's a lot to cover. What we need to do is we need to go ahead and set up our signal connections. So what we'll do is we'll come into our ready and we'll say online match dot connect. And what we'll do is we'll connect player joined, comma, self, comma, and we'll say quote player joined. And I'm just going to copy and paste that a few times because there's quite a few signals here. So we'll say player underscore left, and we'll say player left. And this one probably won't get called, at least in our tutorial, because we're not really using that one, but I want it there just in case. And we'll say player underscore status underscore changed. And we will say player status changed. And then we'll go ahead and put in match underscore ready. And we will say match ready. And then we will go ahead and say match underscore not underscore ready. And we will do match not ready. All right. So now we got to create functions for these. So we'll say func player joined. Whoops. And if we go and we look for our player joined, so if we go to online match and we look for player underscore joined, if we go up, you can see that there is a signal that passes in our player. And same thing with player left, player status change. Looks like we have player and status. So we can use that. Match created, match joined, and matchmaker matched. So, okay, so it looks like they all pass in one except for player status changed. So player status change, we're gonna have to make it so it pulls in two. So we'll say player, and we'll colon pass for now. So that way we can create the rest of our functions. I'm gonna copy this and paste, paste, paste. I believe we have 5, so we'll paste that again. And then we'll say on player left, player, on player status changed, passes in a player and a status. On match ready, it passes in a, I believe, player. Let's go check. On match ready, it does pass in a player, so that's good. Match not ready also passes in a player. So we should be good to go right like that. Perfect. So basically what I did was I just scaffolded out everything that we need for our ready screen. So now that we have our signals connected here, let's go ahead and set up our player screen. So when we have a match, we're going to want to tell this screen to go ahead and actually start displaying our players. So what we can do is let's go ahead and add in our players. So what I'll do is I will say func add players. And what we'll do is we'll pass in our players. And then what we can do is we can go ahead and say for ID in players, then let's go ahead and add ourselves a player. So what we'll do is we'll say if var status is equal to, and we're going to need to get an instance to that object that we created, our little ready user ready object. So what I'm going to do is I'm going to come up here and I'm going to go ahead and do that. So I'm going to say var player ready is equal to a preload. And we'll go ahead and preload our res : / and we're going to go ahead and put in our user ready. So user ready.tscn, and that'll allow us to instance that object. And then we'll come down here and say player ready dot instance just like that. Or I guess we probably should call it user ready, since that's kind of the name of the actual scene. So we'll just say user ready.instance instead. And what we'll do is we'll go ahead and say $VBox container dot add child, and we'll go ahead and pass in our status object here. And honestly, we might want to just use user ready instead. That'll make it a little bit easier to understand what's going on here. So we'll say add child user ready. So we're going to create an instance of that user ready object, and then we're going to add it as a child. And then what we have to do is we have to go ahead and pass in our name. So we'll go ahead and say user ready.initialize. And I believe we called it set username, and we'll go ahead and pass in our username. Now, with this player's object, you have to actually pull back our ID and then quote username, and that should set our player's ID. Okay, so what we can do now is we can say, okay, when the person finds a match, we're going to go ahead and add our players. So what we'll do is we'll come into our find match section where it says here that we found our match on match found players. And what we can do is we really could just grab online matchmakers, right? And just go ahead and connect that signal. So we'll go to our ready screen and connect this signal as well. And instead of on match found, we actually could probably just pass in our add players. And that'll basically solve that problem. So what we'll do is we'll go ahead and do that. We'll go ahead and do this. And let's see if that works. So I'm going to delete this. I'm going to go ahead and show these guys. And I'm going to click this, and we will see what happens. Let's see if this worked for us. So we'll go ahead and say email is test@gmail.com. Log in, test2@gmail.com. And we'll log in. We'll find a match. And let's see if they detect our players. This may take a while. All right, so it looks like we do have an error. So user ready.set username ID. Oh, it's because we have to get back our instance. So we'll go ahead and say players ID username, and that'll pull back the proper thing. If we check what our players is, it's a dictionary of objects. So we need to go and fetch that object back. You can see here. So we have to actually fetch it via its ID. So that's my fault. So we'll do that. And let's try that. So I'm going to skip ahead and let you guys, instead of showing you guys the run through of this, we'll just make it nice and quick. And there you go. You can see we have our test and test 2. Both are not ready. Now, if we click ready, nothing's going to happen, but we do have it actually working, and that's a good sign. So to hook up the I'm ready button, what we're going to need to do is we are going to need to do what's called an RPC call, or a remote procedure call. Okay. And what we can do is we can come down to our on button down, and we can go ahead and say, we're going to go ahead and broadcast a signal here, because we're going to need our game manager to pick this up, which we don't have a game manager yet, but we're going to need to build one because we need someone to manage the states and the players and things like that. So what we'll do is we'll come in here and we'll say on button down, and we're going to go ahead and emit a signal here, and we'll emit signal, and we're going to go ahead and emit. we'll pass in emit signal player ready. And then what we're going to do is we're going to come up here and we're going to say signal player ready, and we'll pass that in so that way we actually have our signal here. And then what I'm going to do is I'm going to create a game manager that's going to kind of hold our state. So we'll go into our node 2D, we'll right click, attach a script, and we'll just call it main.gd. That's fine. We're going to connect our signal here. So we'll say $ ready screen dot connect, player ready, comma, self, comma, player ready, because this is a local function, so I'm going to keep it with a lower p. I mean, my conventions have been kind of all over the place with this one. So then we'll say func player ready, and we will not pass anything in because our signal doesn't pass anything in. But now that we know our player is ready, we're going to do what's called an RPC synchronization. So what that's going to do is it's going to call a function, and it's going to synchronize data with our rest of our clients. So what we'll do is we'll say online match dot custom RPC, not ID, RPC sync. And then what we'll do is we'll pass in ourself because we want to run our own function, and we'll say quote player is ready, comma, and from here we can actually pass in stuff that we want to pass to that function. So in our case, we actually don't have a function yet, but what I want to do is I want to pass in our ID. So we'll pass in online match dot get my session ID, and that will pass back our session ID. So now from here, what we can do is we can say func player is ready, and we can pass in our ID. Now, Nakama has this thing where you need to register your RPCs beforehand. So we'll do that first. We'll say func underscore get underscore custom underscore RPC underscore methods. And we're going to go ahead and say return. And from here, we can just basically register our player is ready. So we'll say player is ready. Now, I know that this is kind of all over the place, so let me explain this a tiny bit more for you. And actually, this is not supposed to be an object. It's supposed to be a list. So what we're doing is we are RPC calling out right here to run this function. But Nakama doesn't know what this function is, so you need to register it with Nakama by using this function here, get custom RPC methods. Okay? And what we can do is we'll just go ahead and print our ID. Now, that's basically what we need to do to get this function to run, is we just basically say, hey, go fetch out this thing, synchronize it, and then run this function. So now what we can do is if I run through all of this, you'll see me log in real quick, and we'll find a match. All right, so now if I click I'm ready, you'll notice that that ID gets passed between people, which is good. So now what we're going to need to do is we're going to need to go ahead and set our status, right? Remember how we have the name plus its status, right? So what we can do is we can come over to our ready screen, and we can go ahead and say func set ready status, and we'll go ahead and pass in our ID. And what we'll do is we'll say colon var status object, I should probably do a capital O, is equal to $VBox container dot get node or null, and we'll pass in our ID. And then we can say if we have a status object, then we can go ahead and set our status object status. So we'll say status object dot, and if I remember correctly, Our user ready script is set ready. So we'll go ahead and do that. And really, we should probably rename set ready to set ready status, to be honest with you. But that's okay. So we'll say status. And actually, I'm going to go ahead and pass in my status here. So I'll actually do that here, comma status. There we go. And what that'll do is this will actually set our status. So it'll just change our text over for us. Now, if we go back to our main.gd, we're going to go ahead and set our status here. So what we'll do is we will go ahead and say $ready screen dot set ready status. We'll pass in our ID and we'll say that we are ready. And that should allow us to set our status. So now if we hit play and we run this, and then we run test2 at Gmail, and we find our match. I'm probably going to cut all this out because, to be honest, this takes forever. All right, then we're going to go ahead and click I'm ready. And it looks like it's broken. Let's see what's going on. All right, status is ready. ID is that. We go to our remote. What do we got? So our ready screen. User ready, user ready. See, so it's not going to be able to find the object because it says user ready, user ready. These should be the object ID instead of the actual name of the user. So we need to actually change that so that way we actually can pull back our status based off of our ID. Their name should be something like this instead of something like that. So that's my fault. So what we can do is we can go ahead and go into our add players and let's go ahead and set our username. So we'll say user ready.name is equal to our ID. And that should set these guys' names properly. So let's try that and let's see if that actually fixes our problem. Hopefully it does. All right, so if we go ahead and click I'm ready, you'll see we have ready. And if we click I'm ready, you see we have ready. So we have our two guys communicating now. That's awesome. So if you guys wanted to do a text system where you were texting between each other, you actually could just do exactly what I have here. But instead, when you hit enter, you just RPC send that data just like you would expect. So that's how simple it is to get communication to happen. So that's awesome, right? That saves us a bunch of trouble and everything seems to actually be working pretty well. And I'm going to close these guys because it keeps causing errors in my console because of that cyclical reference issue. But we basically have the basics of sending and receiving data between the two. So that's awesome. So now that we have that, what we'll do is we'll come into here and we're going to go ahead and do some checking here. So we need to first determine if we are the network server, right? So we can say if online match dot is underscore network server. And that's going to allow us to determine if we are the master server, right? If we actually are the person that's running everything. Okay, and we need to know this because if a player's ready, we don't want anyone else to keep track of what players are ready and what players aren't ready unless they're the host, right? Unless they're the person that's running everything. And the reason why is because we don't want clients to be able to start the game because then we could get ourselves into some weird states. So we want to make sure that we check for that. So we're checking to see if we're network server. And then we want to go ahead and store our player, right? Because we need to store if that player is ready or not, okay? So what we'll do is we'll scroll up here and we'll say var ready players, and we will make that equal to a new object here. And then we'll come down here and we'll say ready players And I'm going to pass in that ID, and I'm going to say is equal to true, right? Because we're saying that that player is ready. And then we're going to check to see if our player, ready players, is the same size as our connected players. So we'll say ready players dot size is equal to our online match dot players dot size. So remember, we have a online players here, right here in our online match. We actually have all of the players that are currently connected to our client. So we want to make sure that all of the people that are connected to our client are also currently ready. And if they are, then we can go ahead and start our game. So what we can do is we can say online match dot start playing, and that'll start our game. And then from here we can actually do our own code. So we can just say start game, and that'll go ahead and start our game. Now we don't actually have a start player, or start game I should say, so we're going to need to code that, right? So we'll come in here and we'll just say func start game, and we'll go ahead and print all players are ready. Let's start the game. Simple enough, right? So now if we run this, and I will definitely skip ahead, but once we run this, it will hopefully work for us. So now I'm going to click I'm ready. I'm going to click I'm ready. And if everything worked, it should have given us a print. So it should have worked, but you'll see that we don't have any console messages here. And the reason why is because this object here was not chosen as the master of the project, right? Or the server, right? So if we actually look at our console and we look at it, you'll see that we have an all players are ready, let's start the game, but we don't have it here, right? And the reason why is because the one that got executed that's not connected to our editor got chosen as the server. And so it's going to show up in here instead of showing up in here. Don't ask me why. It's pretty random on which one gets picked. So you'll have to pay attention to both just to be sure. But on the bright side, it's working. And that's what we wanted. So what we can do now is we can go ahead and start our game. Okay, so now we have to spawn our players, hide our UI elements, and get everything moving, right? So what we can do first is we can say $sign control dot hide, and that's going to go ahead and hide our user interface because we don't want this to be showing, right? We want it to be gone. So we'll hide that. And then what we'll do is we will go ahead and set up our spawning system. Okay. So what I'm going to do is I'm going to right click, add in a child node. I'm going to add in a node 2D like that. We'll pass that in and we will call this players, and right click, add in another child node. Let's add in a node 2D and let's call it player spawn points. And then let's go ahead and add in another child node and add in a position 2D. We'll kind of zoom out here and let's move this guy somewhere like this. And let's just call this player 1. We will duplicate this a few times. So player 2, we'll bring him over here. Player 3, in case you want to do 3 people, and 4, in case you guys want to do 4 people. We'll place them like this. And then what we can do is we can go ahead and go into our players, right click, attach a script, and let's just go ahead and attach a player manager script. Just like that. And that's the player manager script will not be used for the specific player, but it's going to be used to manage all the player states. And really, we should probably rename this as game manager instead. So let me actually rename this real quick because I think game manager is probably a better title for it. So let me rename this as game manager and let me make sure that that's happy with that change. So what we need to do now is we need to actually create our characters, right? And create our character controllers and create all of that stuff. And that's going to take a lot of work. So, I guess let's go ahead and jump right into it. So what we're going to do is we're going to go to scene, new scene. create ourselves a 2D scene, and this is going to be a 2D character controller. And the reason why is 2D character controllers are simple, but if you want to do a 3D character controller, you can. It's not much different, but it is slightly different. So just keep that in mind. Now, what we're going to do is we're going to go ahead and make a small little character that can just like shoot a bullet maybe, and can move, on the XY or the Y, what is it? Yeah, XY axes. So what we'll do is we'll first drag in an icon here. I'm just going to use the Godot sprite here. So we'll just kind of drag that in just like that. And we'll go ahead and just kind of make it about center, give or take. So we'll just kind of put it right about here. And then what I'm going to do is I'm going to right click, and I'm going to change this node 2D type to a kinematic body 2D. I'm going to go ahead and right click, add in a child node. I'm going to add in a collision node right here. So we'll add in a collision shape, and we'll go ahead and add in our rectangular shape. So I'm going to drag this guy up to be about this big, give or take, and I'm going to right click, add in another child node. I'm going to add in a position 2D. I'm going to move that position 2D to be out in the front, and this is where our bullet's going to fire from. Okay, and I know I'm going really fast, but the reason why is because, I don't really want to spend a lot of time on creating a character, because it's more about how Nakama works. So what we'll do is we'll click on here, we'll change our name to player. We're going to go ahead and right click that and attach a script, and we'll go ahead and attach a player.gd script here. We're going to create a real simple player controller, and we're going to have some changes here on the way. So first, what we need to do is we need to go ahead and come up here, and we need to say export, and we'll call that a Boolean. That way we can actually have it as a Boolean, and we'll say var player controlled, and we'll make that equal to false by default. Now we're also going to put in a vector for our movement, okay? And we're going to make that equal to a vector 0, so colon equal to vector2 dot 0. And then we're also going to pass in a look at vector. Now, I know you're kind of wondering, why am I going through all of these things? And I'll explain that in a minute, but basically it has to do with variable synchronizing. So we can synchronize our variables and things like that. Now, if you guys remember, we want to be able to move our object around. So let's go ahead and say func underscore physics process. And then we'll go ahead and say if we're player controlled, because we don't want this to run if a player is not being controlled. We're going to say if player is currently controlled, vector is equal to vector2. And we'll say if input dot is action pressed, and we'll go ahead and say UI down. So UI underscore down, which it didn't quite pick up with my syntax highlighting, but that's okay. So I'll do that. And we'll say if it is action pressed UI down, then what we're going to do is we're going to say vector dot y plus equals 1. And then I'm just going to basically grab this little bit of code here, and I'm going to go ahead and copy this a few times. And we'll go ahead and pull these guys back. And what I'm going to do is I'm going to say if UI up, we're going to minus equal 1. We're going to change this to X, change this to X. We're going to say UI left, and we'll make this minus 1, and UI right, and we'll make this plus 1. Simple enough. And then what we can do is we can say vector is equal to move and slide vector multiplied by 100 comma vector2 dot up. And what that's going to do is it's going to allow us to move our object around. And then what I want to do is I also want to look at our mouse position. So I'll say get global mouse position. Now that's going to allow us to move our player around and allow them to actually look around. So if I save this and I save my new scene and I play this scene, you should be able to see that I have my guy and nothing's happening. And the reason why nothing is happening is if I look at my player, you can see I have a player controlled. So if I turn that on and I hit play, which I hit the wrong play, so that's not going to work. So let me hit the correct play. You'll see now I can move this player around and that works perfectly fine, which is exactly what we want. So now what we can do is, and I have all this code in my GitHub, so you guys can just use it if you don't want to build a character controller. And I totally understand because creating it from scratch is a pain. Now, what we have to do is we have to add in our ability to shoot. So we'll say shoot var, or we'll say if input dot is action just pressed, and we don't actually have a shoot button. So what I'm going to do is I'm going to go to project settings. I'm going to go to my input map, and I'm going to say shoot, and I will add that. And we are going to go ahead and make that into a mouse button, and we will say on our left mouse button pressed. So we'll say quote shoot. Then we will go ahead and say, and we need some kind of object to shoot, right? So we need to create some kind of scene for that. So let's go up to our scene, new scene. Let's create a 2D scene, and let's come in here, right click, and let's change our type to an area 2D. So I'm going to go ahead and change type here to area 2D. I'm going to right click on that, add in a child node, add in a collision shape, and I'm going to make that into a small little square here. I'm also going to drag in an icon here, and let's go ahead and make this smaller because this icon is huge. So I'm going to go ahead and make this guy into a nice teeny tiny little bullet-like sized guy. So I'll make him about, I don't know, about yay big, give or take. So we're going to bring him about there. We're going to grab our collision shape, make this guy just a little bit smaller as well. And I'm going to offset him just ever so slightly off to the right. So that way when he instances in, he's firing out instead of firing, instead of instancing in halfway, it's going to instance in fully. And now I'm going to rename this to bullet, and we're going to right click our bullet. We're going to attach a script, and we're going to call it bullet.gd. And from here, let's go ahead and create a very quick bullet script. And bullets are really easy. So basically what we'll do is we'll say var speed, and we're going to make that equal to about 750. We're going to say var player who shot, because I want to know which player shot it so that way they can't shoot themselves. Var time to live, and we'll make that 100 seconds. That should be plenty of time. And then what we can do is we can come into our processes, and we can say func physics process, and we can say time to live minus equal delta. If time to live is less than 0, then let's go ahead and queue free. Let's just go ahead and delete ourselves. Outside of that, let's go ahead and set my position plus equals transform.x multiplied by our speed multiplied by time, so delta. And what that'll do is that'll produce a constant rate of fire. So when you shoot this, it's going to go on the x-axis by speed times delta. So it'll provide a very fast bullet that is dodgeable. Now, what also we need to do is we need to go ahead and set up being able to kill people, right? So let's go to our bullet. Let's go to our node. Let's go ahead and attach it on our body entered. So we'll go ahead and do that and attach it to our bullet. And then let's go ahead and print that we hit our player. So hit player plus str body. And I'm going to go ahead and save that. And like I said, I know that I went really fast. And if you want this asset, just go ahead and go to my GitHub and download it. It'll save you a lot of trouble. Now that we have this, let's go back to our player script and say, if our player shoots, then we need to go ahead and shoot. So I'm going to go ahead and abstract this out as a function because I'm going to need this later. So we'll say func shoot, and we're going to pass in a shoot position, and we're going to pass in the player who shot. And what we'll do is we'll say var bullet is equal to, and we need to be able to instance that object. So what we can do is we can either A, resource load it, or we can make it a pack scene. And I think I'm going to go ahead and make it a pack scene. So what we'll do is we'll come up here and say export var bullet as a packed scene. And then what we can do is we can come down here and say bullet is equal to bullet dot instance. And you'll see that it's still mad about this, so we'll just pass. Actually, we'll just call shoot for now. And what we'll do is we'll pass in our shoot position, which in this case is $. If I remember correctly, it is a area to our position 2D. So position 2D, that's where we're shooting, and our current name. Now, I'm just solving that problem real quick. Now, we need to go ahead and after we instance our bullet, we need to put it somewhere. So what we can do is we can say get tree dot get nodes in group, and we need to get a group. So what I'm going to do is I'm going to create a group on my main project here. So we'll call this main. Whoops, I spelled it wrong. Main. And I'm going to go ahead and attach it to the main game world group here. And I'm going to come back over to my player here. And I'm going to say get back my game world. And I'll get back my first instance, which should just be that. And what we can do is we can go dot add underscore child, and we'll pass in our bullet. And that'll basically spawn that object into the world. And then what we can say is bullet dot transform is equal to our shoot position. And that will basically allow us to shoot. So now if we hit wrong button, if we hit play, now we should be able to click and you'll see that it crashes. And the reason why is because we forgot to put it into our inspector. You can see bullet is empty. So let's go ahead and add our bullet and let's retry that. And we still have an error. Get nodes in group game world. That's probably because our game world doesn't technically exist yet. So what I'll do is I'll add the player to the game world for a second for our testing purposes. So we'll add that. And then let's see if that works. And the reason for this error is that we need to come up here to our shoot position and do dot transform instead of just passing in our object. So that was my fault. And then what we can do is we can go ahead and test this. So if we click on our little scene here and we click, you'll see that now we can shoot. So that's good. Now it's following the character, and that's fine for now because we won't have that problem when we get to the actual project, but at least we know that we have everything working. So now what we have to do is first we need to get rid of our game world here. We need to come to our inspector, shut off player controlled because we don't want to control it anymore, at least by default. And then we need to go over to our player controller. And what we need to do is we need to go ahead and set up our synchronization stuff for our project. So what's going to happen is we're going to run through if our player is controlled, right? We're going to run through all of this code, and then we're going to say, hey, run this function on all of the clients in the project. So what we can do is we could do what's called a custom RPC. So what we'll do is we'll come down here and we'll say online match dot custom RPC self comma quote update remote players comma, and then from here, just like most RPCs, we can just go ahead and put in whatever we're trying to synchronize. So in this case, we're going to need to synchronize our player's movement. So that would be their position, right? And their rotation, because we want to have their rotation and position. And we're going to also want their current vector and whether or not they're shooting, right? Because we're going to need to be able to run the shooting code on their end. So what we have to do is we have to create a Boolean right here. So we'll say var shooting is equal to false, right? And then here we can go ahead and say shooting is equal to true because they are shooting if they click down. And then we can pass in shooting. Now, what we need for our shoot function is we need the shoot position and the player who shot. So let's pass in our $position2d.transform, and we can pass in our name of our player who shot. Now, it says my identifier position. Now, you can see that we have an error here. It says identifier position isn't declared in the current scope. I'm guessing I spelled position wrong. Yes, I did. So now what we have to do is we have to create a function called update remote players, much like how we did in our ready screen here. You notice that we have, if I remember correctly, where is it? I think it's actually in our main.gd. You can see how we have our get custom RPC methods here. And you can see how we have our custom RPC sync is player ready. And then we have our is player ready right here. So we need our custom RPC method. So I'm just going to copy that. And I'm going to come into my player.gd. I'm going to come up here. I'm going to paste that in here. So that way we have that. And it's going to be called update remote players instead of player is ready. And then we're going to create a function for that. So func update remote players. And we need to pass in our current position, our current rotation, if we're shooting. And then I believe we had a couple more. So we had our shoot position and our player who shot. And I'm going to go ahead and kind of clean this up so it actually makes sense. So current rotation and current position. There we go. And then what we'll do is we'll come in here and we'll say, okay, we need to update all of our values, right? So we'll say global position is equal to current position. And we'll say rotation is equal to current rotation. And we need to determine if we're shooting. So if shooting, right, then we need to call our shoot, right? And we need to pass in our shoot position, comma, our name. I believe we called it name or player who shot. I believe it's player who shot. So we'll say player who shot. And there we go. So now let's go ahead and test this. And if we have done it correctly, we should actually have our movement system working. So now that we have this should be all we need to synchronize our players. But unfortunately, we're not going to be able to test anything until we get our spawning system working. So what I'm going to do is I'm going to go into my, I believe it was game manager here, which is where we started before we did all of this. And we're going to set up all of our spawning code. Now, this is where things get complicated. So what we'll do is we'll first go ahead and have our player scene. So we're going to say var player is equal to preload, and we'll go ahead and pass in res://player.tscn, and that'll allow us to go ahead and instance our player. And that's this scene right here. And then what we're going to do is we're going to go ahead and create a function called start game. So we'll say func start game, and we'll go ahead and pass in some players. Okay, and that's basically going to be the players that we are going to start. So what we'll do is first we need to run an RPC synchronization. So we need to tell all of the clients, hey, I need you to start your game, right? So we'll say online match dot custom RPC sync self, comma, setup game, and then we'll go ahead and pass in our players. And then if we do that, we can actually go ahead and come in here and say func setup game and pass in our player just like that. And we're going to need to do our custom RPC code here. Remember, we have to do our get custom RPC methods function. So we can just go ahead and go to our player script and grab that because I don't really want to, code it. So we'll come in here and just paste it. And we will go ahead and say setup game, like that. And then we can go ahead and on our setup game, what we need to do is we need to keep track of a few things. We need to keep track of what players are alive. We need to instance all of our players, and we need to set which player is our player. Okay. And what we can do is first, we're going to make a var players, and we're going to make, I believe we should make that a object actually, like that. Var alive players. And I think that will be it for right now. And what we'll do is we'll say players is equal to players right here. I actually think it should be like that. That'll work. And then we'll go ahead and say alive players is equal to players as well. So that way we can have our players and our alive players. So that way if we need to go and fetch any additional players that's not just currently alive, we can. And if we only want to tell the alive players things, we can do that as well. So for instance, if somebody dies, we could say, we don't want you to get any more updates on where player positions are, right? We could set that up if we had it, if we're doing it this way. You see what I mean? So what we'll do is we're going to go ahead and say for ID in players, I want to go ahead and instance a player. So var current player is equal to player.instance. And then I'm going to go ahead and say current player.name is equal to our player ID. So str ID. And then we're going to go ahead and say $. And if we look at our main scene and we make sure that we have our game manager here, we have a players spot here. So what we'll do is we'll need an object to put our players under. So I'm going to right click this, add in a child node, add in a node to D, just like that. And we'll just call this players spawn under. Will work for me. I'll go ahead and click on my script and I'll say players spawn under dot add child current player, and that's going to go ahead and add our players underneath this little object here. Now from here we need to tell our player who the network master is. So what we'll say is current player dot set network master as our ID. Okay. And then we need to set our player's location based off of where their ID is. So these IDs are going to be like 1, 2, or 3, or 4, right? So what we can do is, that's why we named these things player 1, 2, 3, and 4. Okay. So what we can do is we can go current player dot position is equal to get node player plus str ID dot position. There we go. And that should give us back exactly what we want if done correctly. If this is done correctly, we should be good to go. So now what we can do is we can go ahead and say var my ID is equal to online match dot get network unique ID, and that's going to pull back our unique network ID, so that way we know what our ID is. And then we can say var $ player spawn under dot get node str my ID, and that's just going to pull back our player. And then we can just say player dot, and I believe we called our control player controlled. So we'll go ahead and say, if I can get back to my class here, player controlled is equal to true. So we're going to tell our player that we are under control of our own player. So now we have to synchronize our state, right? We've spawned our players. We've set which player is us. And now we need to be able to tell our network master that, hey, we are done setting up. And the easiest way to do that is to use custom RPC ID sync. So what custom RPC ID sync does is it lets us tell a specific ID that we're done with a thing, or we're running a function on that master node. So what we'll do is we'll go online match.custom RPC ID sync. And the difference between custom RPC ID and custom RPC ID sync means custom RPC ID will run only the function on the object that we're telling it to run. Custom RPC ID sync runs it on both the client and the master object, if that makes sense. So we'll go ahead and say self, comma, 1, comma, and our function will just say finished set up. And we're going to go ahead and pass in just our ID. So we're going to tell them that our ID is finished setting up. Okay. And we're going to need to come up here and add in finish setup just like that. And we'll pass that as a quote. So quote. And we'll go ahead and make this function right down here. So we'll come down here, hit enter, enter. Func finish setup, and we'll pass in our ID. And then we'll go ahead and set up the rest of our synchronization. And inside of our finished setup, we're going to need to check if the setup players equals the number of players that are in our project. So first, we need to create an object up here to keep track of all that. So we'll say var ready players is equal to an object. And we'll go ahead and come down here and say ready players ID is equal to players ID. And then we can go if ready players dot size is equal to players dot size, then we're good to go, right? We can get started. So what we'll do is we'll go ahead and tell our game manager that we are ready to go ahead and start. So what we can do is we can come to our game manager. You can see how I have the start game where we're doing this. I wonder if we should go ahead, instead of start game, what if we do this instead? So we'll go ahead and do start game. So we will say get tree dot get nodes in group. And I believe I have a main function here called game world, or a main group here called game world. So we can go ahead and grab that game world 0 dot, and I believe it was called start game, right? So just start game. And if you want, you could go ahead and fire off a signal, and that would be perfectly fine and acceptable. But I'm going to do it this way because I like to be complicated and a pain in the butt. So I think that'll work. Now, that's going to go ahead and fire that off. We're going to need to tell these guys to set up the game. So let's go ahead and run our start game. So what we can do is we can go into our main and say, okay, when we're ready, $players dot, I believe it was start game, right? So we'll go ahead and copy that and go back to our main start game, and we can pass in our players. So I don't know if we do have a ready player, so let's pass that in. I think that might work. So we'll pass that in. Not players is ready. We can pass in our ready players just like that. And that should, in theory, work. So let's go ahead and test this and see what breaks, because I can almost guarantee you something's going to break. So let's see. We'll click I'm ready. And we definitely have a crash. Invalid type function is set network master in base, cannot convert argument string to integer. So set network master. This is in our game manager. It actually got really far. I'm actually kind of surprised it got this far. I figured that with us doing all of this that it would be completely broken. So let me see. Is ID a... Okay. Does our players... Oh, we might not want to pass that directly. Let me see. So right now we're passing our players. And let me actually kill this so that way it doesn't blow anything up. So right now we're passing our players. And if we trace this back, I said to pass in... And instead of passing in our ready players, let's go ahead and pass in a different thing. So let's go ahead and pass in online match dot get player names by peer ID instead. And let's see if that will work better. So let's go ahead and test that real quick. And I'm going to fast forward so you guys don't have to stay here through me logging in and waiting for Nakama and all that stuff. Well, we got a little bit further this time. I think. Let me see. Ready players. Did we actually get further this time? I don't even know. It's so hard to tell. Did we spawn our players? Well, it doesn't really say. If ready players dot size. Non-existent size in base dictionary. Okay. Dot size is equal to our player dot lowercase s size because I'm dumb. Let's try that again. I will be right back and see if this will work. All right, it looks like it worked, kind of. So we can rotate our character and we can move him around and the game seems to synchronize state. When we click, it doesn't shoot, which is always a good sign. You can see that my ready function here is still existing and our output isn't firing out anything and we're not really shooting anything, but we can move. So everything's actually working at least somewhat correctly. So that's awesome. So now what we have to do is we're going to need to kill this because there's a whole bunch of error handling we're going to have to do here. But we do have it at least working. So now let's go ahead and take a look at our shooting code and see if there's something that's missing. So is action pressed shoot? Go to project settings. Let's see, shoot exists. Device left button. So that's correct. We did test this and it should work. Now, if shooting, we're passing our shooting in. We're passing it in and we're checking here. So that should, in theory, work. Let me see. So I wonder if it's even getting past any of this, if it's actually instancing the bullet or anything like that. So let's go ahead and do print shooting, and then we'll go ahead and also print shooting 2 here to see if it even fires off. Now, the other thing is that on our, I think, client, it's not getting rid of our game ready bar. It's not actually getting rid of our control node like you would expect it would. So my guess is because I'm doing it under start game, if we look at where start game is ran, so we're saying players.start game, we should probably move this up because this only runs on our master node, right? Because we're doing a custom RPC. If I remember correctly, if we go over to players, let's see. If we go over to our game manager here, our little players manager guy, and we come in here, we're doing a custom RPC ID sync right here, and we're firing it off here and saying, hey, game world, start game. So actually what we should probably do is we should probably take this, get rid of this, and go ahead and just put it here. And that'll probably solve that issue for us. And then what we can do is we can go ahead and test this and see if we can get shooting to work. So I'm going to run through, test this, and I will be right back. Now, you can see we do have shooting, and we do have shooting 2. So we can at least verify that it is, in fact, attempting to call the shoot code. Now, the question is, why is this not working here? So I think I figured out what it is. I think this needs to be global transform. So if we go dot, I think it's global transform. I don't think we want to pull back our local transform. I'm pretty sure we want to pull back our global transform. So what we'll do is we'll grab global transform for both of these guys. And I'm going to go ahead and test this, and I will be right back. All right, now if we click, we can shoot, and it works like we would expect. Now, our ready function still isn't going away properly, so this must be host, and this must not be host. So that's not good. Now, if we shoot at the player, you should see that we are doing a hit player. So we now basically have a game on our hands. So you can see I'm hitting the player, I'm shooting, and everything seems to be working. Now, we do have that small bug currently with this, so let's go ahead and get rid of that and figure out what's going on. So what I'm going to do is I'm going to go ahead and go over to my game manager. I believe we get rid of it underneath our... So what we're going to need to do is we're going to pull this guy out completely from this is player ready. And what we're going to need to do is once the game has started, we'll need to go ahead and tell everybody to do this at a different time frame. So what I'm going to do is I'm going to come into here. I'm going to make a func hide our match make interface, and I'll just go ahead and put that in here. So I'll just say $ control dot hide. We'll just go ahead and hide that control object. Okay. And then what we'll do is we'll just grab this and we'll just go ahead and do under our game manager. Once our project is done and we've done our RPC sync finish game setup, what we'll do is we'll go ahead and say get tree.get nodes in group, and we'll go ahead and get our main node, which is game world, and then we'll come over in here, paste that, get back our first instance dot, and I believe we called it hide matchmaking interface. So we'll go ahead and pull that. And that should go ahead and fix this issue. So if I test that real quick. All right, that got rid of it for us. So now we should be good to go. So hit player 2, hit player 1. Nice. So we're good to go here.
Okay, so the next big thing that we need to do is we need to make it so that when you shoot a player, it kills that player, right? Right now we have it so that when we hit a player, it logs their body, but it would be good to have something that we can do to kill off our player. So what we can do is first we can say if body.name does not equal player who shot, then we can go ahead and do damage. We can kill the player off, right? So what we can do is we can say if online match dot is network master for node, and we'll pass in ourself, then we can go ahead and RPC sync our death function. Okay, so we can do is we can say online match dot our custom RPC sync, and we can go ahead and pass in our body comma quote die. Now we don't actually have a function called die, so let's go ahead and create that real quick. So if we go over to our player and we say func die, we can just go ahead and queue free for now at least, and in the future we can make this a little bit more fancy. And also, since we're doing an RPC sync, we need to add it to our RPC methods. So die just like that, and let's go ahead and test that. And there you go. You can see that we officially killed off the player, and that was very successful. Awesome. So now what we need to do is we need to go ahead and make it so that when the player dies, we can notify everyone and say, hey, game over, right? We win, right? Or we lose. So what we can do is we can go ahead and create a signal for that. So we'll come up here and say signal player has died, and then we can go ahead and emit that signal down here. Just like that. And that'll basically just notify anybody that wants to listen to that a player has died. Simple enough, right? So what we can do is we can go into our game manager here, and we can go ahead and listen to that signal when we do our spawn, which, if I remember correctly, is right here. So we can go ahead and say current player dot connect, and then we're going to go ahead and connect our die signal here to all of our players. So each individual player will have their signals connected, so we can run a single function for that death. So if we go over to our player, you'll see that we have a player has died signal. So we'll go ahead and connect that. So we'll say player has died to ourself. And what we can do is we can say on player death, and we'll come down here and make a function for that. So we'll say func on player death, and we may want to pass in our player ID because that might make things a little bit easier. So we'll just pass in an ID here, and we can come up here and say, where did I put it? Right here. We can go comma and give an array and pass in our ID as well. That way, when our player dies, it passes in its ID and we know who died. And now from here, what we can do is we can go ahead and do live players dot erase our ID. And then we can go ahead and say if live players is equal to 1, or if it's less than or equal to 1. And what we can do is we can go ahead and create a signal that basically just says, hey, game over, right? So we'll go ahead and create a signal for that. So we'll come up here and say signal game over. And I should probably stick with a good naming convention here. So game over. And then we can come down here and say emit signal game over. And if we want to, we could pass in the alive players. And that'll just pass in all the players that are alive, that are currently, still alive. And what we can do is, now that we have our little signal here, we're going to need to listen to it from somewhere. So what I'm going to do is I'm going to go over to my main script, which, if you remember, our main script is right here. So what we're going to do is we're going to grab this main script, and we're going to go ahead and attach that RPC method. So we'll say $, and I believe I had it underneath players. So players dot connect game over. And if I remember correctly, we're going to pass that to ourselves, and we are going to call it on game over. And if we look at our game over code, let's go down here, emit player with the alive players. So we can do is we can go over to our game over, create a function called on game over, and we'll pass in the alive players. And what we can do is we can go ahead and just tell everybody that the game is over. So what we'll do is we'll say online sync self, comma, determine winner, comma, alive players. And that's going to allow us to fire off an RPC. So we're going to need to go ahead and come in here and make func determine winner. And we'll say alive players. So to determine our winner, what we need to do is we need to determine who's all still alive and who's not. Now, if you remember, alive players is a dictionary. We can just make that into a dictionary. What we can do is we can basically say if our session ID is in the dictionary, then we're good to go and we've won. If not, then we've lost, right? So what we can do is we can say if online match dot get session ID in, and we can say alive players, then print I win, else print I lose. And we're going to need to pass in our session ID. We'll pass in self, see if maybe that does it. Well, let's go ahead and do this first, because I'm not sure. We'll print our alive players, and I'm going to go ahead and Control K to comment that out. Let's just run this and let's see what happens real quick. We'll click I'm ready. I'm going to shoot this guy, and we've got an error, I think. Dot size, I believe dot size is going to work there. But if we look at what this is it's our alive players 2 colon test 2. So what we could do is we could keep track of what my ID is. You can see we have online.get unique network ID, and that will pass back probably our 1. So what if we just grab this and then check for it in our manager? So if we go to our main and we do one of these numbers where we Control K, and then we say if online match.get session ID. So instead get unique ID, and let's try that real quick. And let's see if that works for us. And you can see I win, I win. So what we can do now that we basically have a small game loop going is we can go ahead and right click our main, add in another child node, add in a control node here. And I'm just going to kind of center this. And I mean, I'm not going to go into how to create an entire game loop or anything like that. You guys are more than capable of figuring all of that out. But what I will do is I will put a label in the center, and I'm going to go ahead and put this right about here. And what we can do is we can say you lose. And what we can do is we can go into our main, and instead of printing I win or I lose, we can just go $, control2 dot label dot text is equal to I lose, and do the same thing over here. Paste I win, and we can also go $control2 dot show, which will show it, and we can just hide this. So that way when the game is done, we can go ahead and actually just show and hide our I win or I lose. So if we come in here and test it real quick, go ahead and click I'm ready. We'll kill one of these guys. And you can see we have I lose and I win. So that's perfect. That's exactly what we wanted. So now the question is, and I know that everybody's wondering, well, okay, so I can run this locally, right, with my Docker instance here, but how could I run this on the internet? How could I host this out on the internet, right, for other people to be able to play? Well, what we can do is we can go out to a hosting site. In this case, I'm going to use DigitalOcean. Now, DigitalOcean is a pay for hosting service. So if you guys use this, you will have to pay for it, although they do have a free trial. And if I remember, I'll leave a link in the description for an affiliate link. And I don't get any money out of the deal, but it does give me free server time, which is useful. And if you guys don't want to run through this setup, I will also put my IP address information for my DigitalOcean server that you guys can use to connect with your Nakama account to be able to at least do your own testing. And that's provided by my Patreons. So thank you, Patreon people, for helping me out there. So what I'm going to do is I'm going to log in. And you'll see that I already have a droplet here, but I'll go ahead and destroy it so that way it's gone. And we'll destroy that droplet so that way it's over. And then I'll go to my droplets. I will go ahead and create a droplet. And what we'll do is we'll go to our marketplace and we'll choose Docker here. We'll scroll down, click on regular SSD. We'll do the $5 a month. And this Docker droplet will be up and available for you guys. Thankfully, my Patreons is supporting this channel. So thankfully we can actually pay for this. And we'll come down here to New York in my case. And for our password, we'll go ahead and set a password here. And then you can go ahead and turn on backups, monitoring, or IPv6 or anything like that if you'd like. And we're going to go ahead and create our droplet. Now you'll see that it's going to say your project information up here, which I've blocked out because it has my email on it. And you will see that our droplet is being created. So we're going to let that run for a minute and I'll be right back. Now you'll see my screen has changed a little bit. Don't worry, just go ahead and click on your droplet here. Just click on that. And then you'll see that you got all sorts of usage data here, which is super useful if you're trying to see how much bandwidth you're actually using and how much CPU you're using, and maybe if you need to upgrade or if you don't need to upgrade. This is really nice for seeing how much data you're actually using. Now, if we go ahead and click on console right here, click on that, you'll see DigitalOcean is going to open up a console here. And you should be able to type Docker, and it should come up with something, which in this case it did. So that means we've done everything correctly. So what we're going to do is we're going to first open up some ports on our firewall here. Now, they use UFW for their firewall. So what we have to do is we have to open up our ports. So we have to say sudo UFW allow, and we need to allow the ports that Nakama uses. Now, if you guys remember correctly, we have our ports listed in our project right here. If we go into our main and we go to our online, you'll see that we have a port right here, 7350. So if we open up our DigitalOcean virtual machine, we can just go ahead and allow that port. So 7350. So we'll say sudo UFW allow 7350. We'll go ahead and hit enter. That's going to allow that port to be used. And now we need to actually compose our Nakama instance. So what we can do is we can just go nano docker-compose.yml. And this will give us a new YAML file for us to be able to build our Docker Compose file. Now, we don't need to do that because if you remember correctly, we copied a Docker compose file right here, remember? So what we can do is we can just use that docker compose.yaml file. So we can just grab this, copy it, and go ahead and go out to our DigitalOcean and right click paste, and that's going to paste that into our project. So we can go ahead and hit Control X, yes to save. We're going to name it as Docker Compose, and we're good to go. So now what we can do is we can go docker-compose up, and it should go ahead and pull and create our volume. All right, so now that our Docker is up, you can see it is running. If I come over here and I change our host to our Docker, so if we come over here and we look, you can see our IP address is right here, 204.48.28.159. If we copy that and we paste it, and we say our port is 7350, if I go into my Docker and I disable my Nakama, so I'm going to stop it real quick. It's going to take some time to close. Now you'll see Nakama is closed. So if I go into my Nakama console here, if you guys remember, we have our Nakama console, and I hit enter, you'll see that it is completely down. It does not exist. Okay. So there's nothing up my sleeves. Okay. Now what we can do is we can go over to our project here. We have our port. If we've done everything correctly, we should be able to hit play and go test1 at gmail.com, password 111. We can register. Test2 at gmail.com, password 111, register. Let's find a match and let's let that run real quick. I'm going to click I'm ready, and you'll see that we are now running through our internet instance. So now we can have multiplayer online, and I'm going to grab one of my friends who's out in California and have him connect to this, and I'll send him the executable, and I can show you guys this working over the internet. So I will be right back.
All right, let's go ahead and ready. All right, and you guys will see that we both are able to move around. You can see I'm going to be moving up and down, left and right, and you can see that we both can actually communicate from a distance. Now you'll see that there is a little bit of stutter in his camera, but I can shoot him, and you can see that I have won. Well, actually I've lost. I think we have our win-loss state. But as you guys can see, you guys can use Nakama to play your games online with your friends, which is really cool. Now, there are some things to notice when you do that. You'll notice that if you're playing around and you're shooting, you will see that we are using about 120 RPCs per second. You can see here when I'm shooting and I'm moving around, you can see how many RPCs it's shooting and the input and the output. And you can also see if I move over to Godot here and I come into my main and my online and I scroll up, you'll notice that we're using HTTP, which means we're not using HTTPS. So we're not doing any secure or TLS transport. We're just doing it through HTTP. So one of the big things about this is if you just do it through HTTP, anybody with a packet sniffer can sniff that data, and that's super dangerous, and you don't want that, especially when people are putting their username and password through the open internet. You don't want people to see that. And there's some other things that we can do to really optimize this. You know, if we did some motion smoothing and maybe a little bit of correcting and stuff like that, and reduce our frame rate for our synchronization. So like I said, we're doing 120 frames per second for our RPC call. So every single frame is being synchronized between the two machines, when really we could probably get away with something like 20 or maybe 30 frames, and that would be fine. So we could probably do, 20 frames and then do interpolation between all of that. The difference between if somebody shoots within 20 frames or if somebody shoots within 100 frames, it's really not going to make a huge difference in terms of the reactiveness of your game, but your mileage may vary. So that's just something to keep in mind. And we can do a follow-up tutorial on that to kind of go over some optimization and some security and some things like that. But that is all I have for you guys today. So if you like this video, go ahead and hit that like button. Hey, if you dislike this video, go ahead and hit that dislike button, because I am here to make content for you guys. Now, this video was a viewer suggested video from almost a year ago, I believe at this point. So it took me a while to get to it, but I finally did. So if you guys have any suggestions, please leave them in the comments below, and I'll be more than happy to get to it as soon as I can. And hey, if you guys have any questions or comments, or if you just want to tell me that I'm bad at coding, go ahead and throw them in the comments below, or hit me up on my Discord. Link is in the description below, and I will be more than happy to help you out, or any of the guys on the Discord, of course, will be more than happy to help you guys out. But that is all I have for you guys today. So thank you so much again for watching, and I will see you all next time. Thanks.